In this short video, what we're going to show you how to do is to check your analytical solution from the last video, or your mathematical solution, using a graphical method. So in the last video, we showed you how to calculate the sum of a force 1 and force 2, one of which was at an angle, and use the sum of the vertical and the horizontal components to calculate what they added up to, and then work out what the resultant force was and at what angle that resultant force was. So taking that into our next question, what I'm going to do is write out the answer at the top. The resultant force should equal 108.7 newtons, and the resultant angle should equal 27.3 degrees. So that's kind of what we've worked out mathematically. Let's do the same question again though, using a graphical method. So I'm going to take the same 100 Newton force, which is acting at 30 degrees, and the same 10 Newton force, which is horizontal. And what I'm going to do is I'm going to use what's called the graphical method. Now the graphical method means we can add these forces together, and to add them we just need to put them from tail to head connected, and then we can figure out what the resultant force is. A little bit like walking in one direction and then walking in another direction, tail to head. So I'm going to grab a pencil for this. The first thing you want to do with a graphical solution is create a nice big horizontal line so that you kind of know what is the horizontal in your drawing. The next thing we're going to need to do is I'm going to start with this first force, force 1, and I'm going to draw that, but I'm going to draw it properly to scale. So I'm going to put a dot down on my horizontal, I'm going to put a protractor down, I'm going to say, well, 30 degrees, and this is not the best protractor, is about that angle. What I'm going to do now is going to draw a line from my dot showing 30 degrees. Now notice I haven't really decided how long my line is, I've just drawn a fairly long line. What I now need to do is draw 100 newtons at a certain scale. So for this particular drawing, what I'm going to do is I'm going to choose a scale of about 1 centimeter equals 10 newtons. If I do that, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 newtons is going to be a 10 centimeter long line. So I've chosen that scale, but you could have chosen any scale. You could have chosen 1 centimeter equals 20 newtons, in which case your line only would have been 5 centimeters long. Now that I've got my 10 centimeter long line, pull my ruler away, and what I might do is just write 100 newtons just so that I've remembered exactly what it is. Now I need to add my 10 Newton force head to tail, so I'm going to just draw another horizontal to try and make sure, and I'm just doing a bit of a guess, this is where the errors in these drawings can come in. Another horizontal line, again I haven't really decided how long it is yet, I've just drawn its action, and because this line is only 10 newtons big, I've got to keep to my scale, and that's going to be as long as that force is. And you can see now much better than I did over here, I've drawn these two forces head to tail in the correct scale. And finally what I'm going to do now, and I'm going to use a different pen so that we can see this nice and clearly, from the start of the first vector to the end of the last vector, that over there is our resultant. And because this is the graphical method and I've done things to scale, I can now measure this line to figure out exactly how long my line is. So here we go, 105, 6, 7, 8. So my line is 108 or 10.8 centimeters long. 10.8 centimeters at 100 newtons. Well, if I just times that roughly by about 10, it's going to give me resultant is 108 newtons, which you'll notice is very close to what I calculated mathematically. If I now take my protractor and I put it over my drawing, I will see, if I look closely, 20 degrees, 25, 26, 26 degrees is the line that I've drawn, and mathematically I calculated it 27.3. So it's not identical to my answer, but very close, and this is generally what you'll find because of some of the errors that you have in your drawing over here. This might not have been exactly horizontal to that line. So that's the way that you can check your analytical solution graphically.